What's going on, guys, and welcome back to a brand new bedpan filled with your favorite gravy. Today we're going to be talking about virtual private cloud, VPC, and NAT Gateways. And yes, this is a networking concept and you need to know networking for this. Well, at least the basics of it anyways. And the reason why I say networking is because AWS does have networking components, but they're virtual. So anyway, let's take a step back and, try to figure out what the hell I'm talking about, okay? Or what this video is actually going to be about. So, in the real world, not in our fantasy lands, but in the real world, if I had two computers that I wanted to talk to each other, I would plug an Ethernet cord from this one going to my switch, and this computer going to the switch as well. Or router, as most of you, well, this is more than router, but anyways, a router that you would, you know what this is. This is a router that you have in your home, but it has a built-in network switch. And those are the 4 ports in the back that you always see. But yeah, I will be connecting these two computers to this router. Now, if I put a private non-routable IP address on each of these computers, 192.168.1.2 and then 192.168.1.3. Then these two computers could share files over this private network. Notice that I haven't put I haven't connected my external internet or the public internet to either the computers or the router. Now in AWS, this network, that one that we just created right here, is actually called a virtual private cloud, VPC. So the EC2 instances that we created still have those security groups on them, and those still take priority, but your instances will also sit within a VPC with private networking addresses, which will allow your servers to talk privately with each other without transversing in the public internet. There's actually several reasons why you would actually use VPCs and all the stuff inside of the VPC. Other than when you create an EC2 instance, by default, you already have a VPC. But anyways, Amazon has a documentation on various scenarios. So let's actually look at some of them. We're going to be looking at 2 scenarios. The first scenario being VPC with a single public subnet, and the second scenario, VPC with public and private subnets. The reason why we're only doing these 2 is because they're the most common ones that we're actually going to be using it for. So in scenario number 1, this has a single VPC with 2 subnets, and each subnet exists in a different availability zone. This is actually similar to what AWS created for us when it set up the default VPC for us. Scenario number 2 over here, again, has a single VPC, but with 2 subnets, or actually both of them have 2 subnets. But the difference between this one and the first one is that one of the subnets is private and the other one is public. So public subnets are subnets that divide up your VPC IP range, and they handle traffic from the open internet, like the fleet of web servers that you see right here. Private subnets down here, private subnets host your instances that you want to fully protect from the internet, such as database servers, as you saw right here, or as you can see right here in the blue squares. Traffic can pass between your subnets, but the public internet shouldn't be able to access any servers in the private subnet. So we're actually going to go over the few first steps on actually how to create this scenario number 2, in the AWS console. So let's go back in there. In here, go to services and type in VPC and hit the very first one. We're going to go to your VPCs. And you should see one. Like I said, this was created by default when you created your EC2 instance. So we're going to create a VPC. Name tag, we could name it whatever we want. I'm just going to name it VPC demo. And for our CIDR block, I'm going to put in 192.168.0.0/16. Now, This /16 is the net mask, and basically it's just a shorthand for saying that the IP range is going to be from 192.168.0.0 all the way to 192.168.255.255. So let's hit create and then close. We just created our first VPC, which is the first step, as you hear here. Now we need to create the subnets inside of our VPC. So over here, let's create a subnet. Go right here, subnet. We're going to create a subnet. And a subnet chops up your VPC's IP range into smaller sections, just letting you know. So let's name this public dash A. You can name it whatever you want. And we're going to pick the VPC, the one that we just created. For me right here, VPC demo. Availability zone, just pick the one closest to you or pick the very first one. It doesn't really matter at this point. You should know your availability zones or what availability zones you want right now. We've already been through that. And in our CIDR blog, I'm going to type in 192.168.1.0/25. So the net mask of /24, or it's 24, not 25, of 24 will indicate an IP range of 192.168.1.0 all the way to 192.168.1.255. Okay, so let's hit create and we're closed. So we just created a subnet inside of our VPC. And then we need to create a NAT Gateway. Now, this is the other topic we're going to be talking about. As you can see right here, we do use NAT Gateways, and trust me, you will be using a NAT Gateway at some point or another. You are going to be using this, and we're going to be talking about that. So, going back into our diagrams, our routers at home create a private network, much like the VPC we just created, that links all of your local computers and devices together, either through wire connections or through wireless ones. I'm pretty sure most of you have wireless. I would suggest you to have wired ones, but that's another topic. Anyways, when your devices have connection, it then routes traffic from the public internet. Let me actually connect it now. Oops, not there. It routes traffic from the public internet to your private network through a technique called network address translation, or NAT. This is actually going to allow your wide area network interface to get a single public IP address from your internet provider like 1.2.3.4 and to share that IP address to all the devices on your local area network or LAN. Let me actually zoom out a bit. Nope, not there. Now when a computer wants to get some stuff from, let's say, YouTube.com, over here, this is YouTube.com, YouTube, YT, I guess. The servers at YouTube.com will see traffic coming from the WAN interface 123. It's coming in, and then when YouTube responds, the return traffic is let me actually do another color. The return traffic is going to be sent to 123.4, and then it's routed to your router, and then the router is going to send it back to the originated computer, which was this one right here. This is the guy that wanted that information. Now let's say some random guy wants to on the internet, like 5678 over here, wants to reach one of your private devices, which is one of these two computers, is going to try to open a connection to 1.2.3.4. And then once it reaches your WAN interface, or once it reaches to the router is just going to drop the traffic. And the reason why is because it doesn't know which computer on your private network it needs to route this traffic to, because no private device, none of these computers actually requested that information. So if this explanation didn't make sense to you, I do have one more explanation, and I'm pretty sure this is going to be more simpler. All right, let me actually zoom out even more and go to this door over here. Now, this is all related to NAT. So with NAT, you could actually think of your router, this router over here, your router, like a door with a single doorknob on the inside. As you can see, this door does not have a doorknob on the outside. Your computers inside the network or inside the door can turn the doorknob and open the door, which will allow two-way traffic to pass with whoever they just contacted with. In this case, in this scenario where this computer wanted to contact to YouTube, once this computer wants to contact to YouTube, it'll open up the door, get that or contact YouTube, and then YouTube will send out a response going back into this door. And then once this computer has that response, it'll close the door. So once that door closes, traffic from the outside cannot get in because there's no doorknob on the other side of the door. In AWS, this is actually called a NAT Gateway. And NAT Gateway is attached to your VPC, and it creates a door to the internet that can only be opened from the inside the VPC. Now your instances can have internet access to reach other services and to download software updates, but no one on the public internet can get into your instances. This is a great way to secure internal servers such as database servers or file shares from outside attacks. But let's say that you need to run a public server at home, like a web server, like most of us actually do, or I would hope so. I do. I have my own server, and I actually do host my server, or try to host my page. I haven't even done it yet from that server. Anyways, the only way to get around that limitation in NAT is to go to your router settings, usually turn on a feature that's called port forwarding, and then that will tell the router to always route certain types of public initiated traffic to a specific computer on your private network. And if you're even a bigger nerd, you might have actually done this before if you were hosting a game server for your friends, Minecraft, for instance. Now, if you did it this way, now the door to your router has a doorknob on both sides, and it can be open from either end. Now, in AWS, when it has two doorknobs or a doorknob on each side, this is actually called a internet gateway. Unlike a NAT gateway that only has a doorknob on the inside, an internet gateway has a doorknob on both sides, and it allows traffic originating from the public internet to open that door and to route to instances within your VPC. And we can actually see this in our console. Let's go into our console. Over here on the left hand side, we're gonna see, where is it at? Internet gateways. Click on it and you should see one. And this one was already created for us by the default VPC. And Amazon already did all this for us, so it doesn't really matter. So in the AWS VPC documentation, what we just saw was actually scenario number 1 right here. But we actually want to do the configuration listed in scenario number 2 over here. And that is the NAT Gateway right here. So to do this, we actually need to go back here and click on NAT Gateways down right here. And then create NAT Gateway. Now for your subnet, obviously you're going to pick the VPC that you created. Okay, for the subnet, you want a private one. Obviously, we do not have a private one. We still have a public one. So we do need to create a subnet for a private one. But since we don't have it, I'm just choosing the public. I'm not even going to save this, by the way. And the reason why is because the elastic IP address is a whole nother topic. So going back to our home router example, this is the IP address that your NAT gateway is going to use on its WAN port. Okay, so when your private subnet servers turn the doorknob and open the door from the inside, they will talk out to the public internet using this elastic IP address. So the public internet will only see traffic coming from a single IP, even though you could have several servers behind the NAT gateway. And this is just like how your router works at home. But like I said, elastic IP is another video because it will take up some time. So that's why I'm gonna just end the video right here. Just know that to create a NAT gateway for your private, you do need to create a private subnet. Right now we have it public, and you need to learn about elastic IP if you want to get ahead of me. So thank you guys so much for watching. I do hope you learned something today. This is going to be a topic that I'm pretty sure most of you want to know about. So please stay tuned, because the next video is going to be elastic IPs and actually using our VPNs to access private subnets. So stay tuned for that, guys. Thank you guys so much for watching. Thank you for spending time watching these videos. I really do appreciate it. And I will see you in the next video. I hope. I really do hope so. Thanks. And I'm sorry that I ended it this way, man. I know I usually do not end it this way, but literally Elastic IP is it's a thing, you know. It's another video like content. That's another topic. It's another thing, you know. So thank you guys anyways, and I will see you in the next video. Bye.